You may have heard that protons and neutrons are made up of smaller things called quarks, but what actually is a quark? Remember this thing, the standard model of particle physics, which contains 3 of the known 4 forces of nature? Here's a much nicer picture to see with all the particles and the forces. The 3 forces or interactions included in the standard model include electromagnetism, the weak nuclear force, and the strong nuclear force, which is typically what quarks are associated to. So you might think that quarks are just particles that feel the strong force, right? Well, not really, because the gluon, which is the force carrier of the strong force, itself feels the strong force, but it's not a quark. So what's the difference between a quark and a gluon? Well, we have to remember that there's a difference between force-carrying particles in the blue ring versus the matter particles in the outer ring. What's the difference between a force-carrying particle versus a matter particle? You see, the difference is that matter particles obey the Pauli exclusion principle, which says that no 2 matter particles can occupy the same quantum state. But you might object and say, wait a minute, I mean, this is an up quark, that's an up quark, they're both in a proton, don't they have the same quantum state right here in the proton? And in fact, they do have the same mass, the same spin, the same charge, electric charge, but what they differ is their color charge, which is the new quantum number that we need to explain the interaction of quarks and gluons. So here, these 2 up quarks actually have different color charge, so they are in a different quantum state. On the other hand, the force carriers in blue are bosons. They can occupy the same quantum state, no problem. So in short, a quark is a matter particle that feels the strong force. But it turns out the quarks have a lot more properties than just the strong force, and I'll keep that for the next video.